Hello viewers, you're welcome to task 2 of our internship project. My name remains Vincent Hope, your instructor. So today we're going to be dealing with exploratory data analysis, which simply in short form is EDA. So what are we going to do in this task? We're going to perform an exploratory analysis on a given data set to identify patterns, trends, and summary statistics. Then we will calculate summary statistics like mean, median, mode, and standard deviation. We'll also visualize distributions using histograms, box plots, and scatter plots. Now, scatter plots, we're going to see some things called about outliers. So let's continue. And we're also going to find correlations between numeric features, and the tools we're going to use in this Python project. We're going to use Python, definitely. We're going to use pandas, which we have used in the previous project 1. We're also going to use matplot library, which I think we used in the previous project. And the new one we're going to introduce is Seaborn, which is also a library in Python. We're going to it. So let's jump right into it. So the first thing we do, as usual, is to create a notebook. So let's create a notebook. Create notebook. Click on it. Okay, so we come here and call it internship project 2. Then we call it exploratory. You see one that we have there, exploratory data analysis. We selected there, so let me just select this one too, because I already did one which I can use as a guide. So we press enter. So our notebook is actually now ready. Let's see how it comes up. Okay, still taking its time. Okay, so let's go to, we are there now. Look at it, Internship Project 2. Now, like usual, we will create our data set. So let's create our data set. Okay, and browse the file. We'll still use the sentiment data analysis. We'll locate where it is located. Data analysis internship. Let's see. Okay, let's see what I will find one. Okay, sentiment. No numbering in front, so I double click this, I select it. So the sentiment data analysis, or we don't even have to create a new data set. We can just simply upload the one we have created before. So let me cancel this. Cancel. Okay, I can go back to my data set, open this. This is the one I just created. Where is the one I just created now? Internship project, let's see, Internship Project 2. Okay, this is the one I had before. Let's see, we just created one, so where is it located? Is Internship Project. Okay, let's just use this one and still rename it. We can just simply call it Internship Project 2. Internship Project 2, and stop there, press enter. Okay, Internship Project 2. So we are going to load the data set, on sentiment analysis. So we come here, just click add inputs. Okay, you can see the data set here is sentiment 1. Just come here and click add the data set. Since we've already created it before, we don't need to add it, we don't need to create it again. So we can cancel here. We see that the sentiment is added. Then this one has a CSV 3, so it'll give us some errors. So let me look for another one. Add input again. Let's see anyone that is sentiment. Okay, sorry, let me select add input, your work data sets. Let me select type in now settlements. Okay, we have sentiment 2. I think this one should be better. Let's add this here. So we have added it. Okay, so it has been added. So let's cancel. So you can see it's here. If I open it now, fine. It has just sentiment.csv. This one has sentiment with a numbering in front, so I can remove this. Just click here and click remove. Okay, so we only have this sentiment 2, so we're good to go. So the next step now is we'll have to load the file as usual. So let's copy our code and explain as usual. So you have just copy this code here, Control C. Okay, here. Okay, sorry, were we using sentiment? Okay, it's like I used the stock price here. Okay, let me work with the stock price. Okay, I'll work with the stock price. Let me add it. Okay, where is the stock price? Let's see. Stock. Oh, sorry. Come back here. Click add inputs. Your work. Data sets. Stock price. Okay. Let me come back here to the notebook. Your work. Data set. So I'm already now in Internship Project 2. So we want to use the stock price. Let's use stock price. We don't want to use sentiment. Sentiment we use for another project. Let me cancel here. Let me check. Okay, fine. This is the price, so we don't need the sentiment. So let's remove this. Remove that. Okay, so we are working with stock price. So let me get the code now from the one I've just already done so that it will be easy for us to do it quickly, managing time. So I come here, we click code, we place it here. Okay, so what are we doing? The first step is to load the libraries for data analysis. So what you do is say import pandas as PD, which we already know how to do that. Then import operating system, and the essence of the operating system is to be able to find the path of the CSV file, which is this one we are looking for here, to find this path, stock price. So the path is Kaggle, inputs, data sets, then your name. This is for my name. Then you put the name of the final folder, which is stock price, which is this one here. Then you run. You will see the details more in lesson 1. Or if I'll just run it. If I run it now, okay, let's see. It takes a while depending on your network. So let's see what it comes up with. The session is supposed to start now. Okay, still taking time. Maybe the network. Okay, it's taking quite a while. So in this case, what do? If it's taking you long sometimes, what you can simply do, you can close the file, go back to the source, go back to the source home, open it again. Let's look at it, Internship Project 2, open it. Then we have the one we are using as our guide. Open this one too, but what is focused is this one. Internship Project 2. Let's see the stock price still be loaded. Let's see whether it will run faster now. Run it, execute the cell. Let's see whether it will execute faster now. Still taking a while. Taking a while. Okay, while that is doing, I think we have a sample so we can see it. It's the same code. I just wanted to do the explanation here. But if we go back to the one that has already been calculated, you can see that what we said, import pandas as PD, import operating system. We now said list it to find out where this file is. So if we run it, let's see which one makes an appearance file. Okay, beautiful. This one has come back, the Internship Project 2. So we know that this stock prices is under Kaggle, input, dataset, the name, then the stock price is finally under stock price. So the next thing to do, we have loaded the data set. Let's display it. So we copy this. So to copy, I copy it. I come back here, open a code box here, and click paste. This also has been explained in the previous internship. So what do? We say we get a variable name data equals to PD, which is the pandas dot read CSV. Now you copy the part of the file. You copy it here. Cargo, you see cargo is here. Input is here. Data set is here. Vincent is here. Stock price is here. You put a slash. Then you put the file, which is a CSV file, at the end. Then you now run to find out. You have data.head to see the records in this file. This first 5 records. So if we run it, okay, you can see the first 5 records. So we have symbol, we have date, open, high, low. So the data has been uploaded into this file. So we are making progress. Okay, now what the question says that what we should perform, okay, and explore that on the given data set, identify patterns, trends, and summary statistics. So we want to first look at the summary statistics, which is actually easier to do, and the code for it is data.describe, or the variable name.describe. So if I simply copy this here, Control C, and come back to my internship program, open a code, and press Control V, and I run it. If I run it, now you will see now, if I describe the file, this will give me a summary statistics of all the data here. It gives me the count. The count is 497,401 records. The mean of the opening trades, the standard deviation, the minimum, the 25%, the mean, which is 50%, the first upper quartile, and the maximum. So this is a description. So we have answered this point here, summary statistics. So let's make progress. So what do we do next? Now the next thing is we want to use a histogram to show the distribution of one of the columns. So we can copy this code here, Control C now, come here. So we want to look at the distribution. Okay, visualize. Okay, let's say we take a distribution using histogram. So let's do this. We're still going to answer these other 2 here, patterns and trends. So let's do visualize distributions using histograms, box plots, and scatter plots. So let's come here. So if I run this code here and I put it, let's understand this code. So this is histogram, shows the distribution of one of the column. Which column are we using now? We said import matplotlibary.pilot as plt, then plt.histogram data open. So we are using this data here, open. We can decide to use high, we can decide to use low, close, or volume, but we decide to use open. Beans 10, alpha 0.5, label high, color blue, edge color black. Plot the title, volume of stocks trade, then plot the show. So if I run it now, okay, you see now that this is the histogram it's giving us now for one of the records. If I want to change to I'm not using open now, I want to use low, for example, I still come here and plot. It will give me the data for low. So each or any of them you want to do, you can do that. Now we also have let's move on. We are going to do histogram for distribution of one column. We have done that already. So now we are going to do a box plot which compares several columns. Now let me highlight it, Control C. Now that's one of your questions here, is to carry out a box plot. This is a box plot. We have calculated summary statistics, which is mean, median, mode, standard deviation. We have done that. We are now creating that data distribution using histogram. We have just done this box plot, so that's what we want to do now. So the code for box plot now, I open the code menu, I press Ctrl V. Now the box plot compares several columns. Now the plot is dot box plots. Now we have the data, which is the one that we read from here, data. Okay, so data.open, one of the columns is open, the other one is high, the other one is low, the other one is close. Then you plot the X ticks, which is 1, 2, 3, open, high, low, and close. 4 of them. If there are 5, it's 1, 2, 3, 4, 5. Then plot the typo, price comparison, then plot.show. Run it. If we run it, this is how a box plot shows. Now, how do you understand what is here? This lower line here is the minimum value. The one in red is the average value. Then the one on top is the maximum value. Everything on top of the maximum value are called outliers, means that they don't stay within the range. And you see these outliers, you see that mostly they are now on the closing. So they are outliers, they are not within the range of the minimum, average, and maximum. So the box plot process. So this is how a box plot looks like. Okay, now we can go on and plot for a scatter plot. Now let me highlight it and Control C. Now before I go there, if I bring here, he said you also do scatter plots. So if I come back here to scatter plots, code here, Control V. So scatter plots show relationship between 2 columns. Box plots show relationship between more than 2 columns, but scatter is for 2. So it is used for seeing relationship in correlations and trends. So we say plot.scatter, data high and low. We want to compare high and low. You can also compare open and close. So plot.x label is high, y label is low, plot.title high, then plot.show. If we run this now, you will see how a scatter plot comes out. Now you can see this is low, the figures for low, and this is for high. And the scatter plot shows like a straight line, and the lines are together in like a straight line. So that is how you do a scatter plot. This is how it looks like. Now, what other thing? Then find correlation between numerical values. Correlation simply means relationship between the numerical values. So what do we use for here? Now, I just wanted to explain. Let me copy this for the purpose of explanation and explain correlation so that you can understand it. Now, I will use Markdown and I will copy here and paste. What is correlation? Correlation measures how strongly 2 variables move together or are related. That means move in the same direction. So positive correlation, both increase together. Negative correlation, one increases while the other decreases. No correlation means no consistent relationship. So that is how to explain correlation. So let me get the code now. I run it now, copy this and Control C. Now I bring it here, click on code here and I run it. Okay, so what's the code now? Correlation matrix is used to find correlation between numerical features. Now the features are opening stock, high, what's the high price, the low price, the close, and the volume. So the correlation matrix is equals to data, which is the data that was where the data was, in bracket features, which are these features here, dot correlation. Print the correlation matrix, which is this. If we run it now, you can see now open has 1 positive correlation, which is 1. Open and high is 0.999, which is also high, which is a positive correlation. Open and low 0.99, which is a positive correlation. Open and close 0.99, positive correlation. But open and volume, you can see it is negative. It has no relationship, has no correlation. So these are just repetitions: high and low, high and high, high and high is high. So if you go across like this, you see it's 1, 1, 1, 1. So that is how it looks like. Okay, so let's move on. Then if you want to plot a graph to see the correlation, let me copy this. Okay, come here, code, bring it here and paste. So what is it? We are going to import Seaborn as SNS. Seaborn as SNS. Now, Seaborn is one of the things you should use. We are finding coloration, which we just did now, but we also want to use graphs. Seaborn is one of the things. We have used pandas, we have used matplot library, we are using Seaborn now. So Seaborn, we come back here. Now I say SNS, which is the Seaborn dot pair plot. It will plot all the variables in pairs, just like these ones are in pairs. Open, open, open high, open low, open close. Then dot data. So let's run this and see how it comes out in a graph. It takes a while because it's actually plotting a large chart. But why it is taking a while, before it comes back, this is what it will give you as a final output. Now it is seen as Seaborn. This is the Seaborn. So this is open. This is opening versus this one here versus open. You get this open versus open. Then this one is open versus high. You can see the coloration process. Then you can see this one is open versus low is here. You also have open versus close is here. And the final one is open versus volume. You see how the graph is. So it repeats itself. This is high versus open. Okay. High versus high. Okay. Then high like that. So let me give you one that is close by. So this is low. Okay, let's take this one which is close. Close versus open. You can see it's a straight line. They move. It's a positive coloration. Close versus high, positive coloration. Close versus low, positive coloration. Close versus close. Still 1. It will give you 1. So it's a very positive coloration. But close versus volume, you see that it's a negative graph. So this is how it looks like. Let's check. Okay, this one too has finally plotted. So this is how you carry out your exploratory data analysis. I hope you have learned a lot from this lesson. My name remains Vincent Hope. Thank you for watching and do have a blessed day. Thank you.